Hello, and welcome back to Bitcoin Basics with me and Daniel. Hello, Daniel.
Hello.
And today we're going to be following on from our discussion of hash and the hash function and talking about proof of work. So we thought we'd start with super basic question, which is what is it and why does it matter?
Okay, well, let me just get my notes here. Okay, here we go. So, the idea of proof of work is that I give you a puzzle and I have an idea about how hard it is to solve. And the reason I do this is to limit the amount of information that I have to look at. So I say, only the people who solve the puzzle I give them are people whose messages I will read. And originally, proof of work was proposed for spam prevention, but the result is that information is scarce, or I should say, there's a class of information that is scarce, and that is the class that has proof of work attached to it. And that's how that is how we prevent double spending in Bitcoin, and we create a consensus. Is we make information scarce. So if somebody discovers a block, then it is not worthwhile to try to create a competing block most of the time. But we're not going to go into that yet. Just touching
Right,
on it.
right.
So
From what I understand, proof of work is generalized concept of which there's a specific application in the Bitcoin context, and that has its own particular features. But if I understand the idea in its general sense, it's a mechanism for taking a vast amount of information and very simply, quickly deciding which bits of information in there you are going to pay any attention to. So only
right.
those
Well,
things that come with a proof of work.
you create the puzzle for other people.
Yeah,
So
for sure. But the reason why you would have it, it's almost like saying, I'm thinking about Willy Wonka and his golden ticket. Um, it's created as a mechanism for processing or preventing large amounts of information from taking up what is specific attention that needs to go to something that's been made scarce.
right. So I've got kind of a more mathematical definition here. So for P is an element of 0 to 1, and that means it's a range. So it's a probability. It's from 0 to 1 inclusive.
Mm-hmm.
Create a function of type n to true or false. So that means that you input a natural number, and I've written that blackboard bold n
Yeah.
is the natural numbers, that 0, 1, 2, 3, and so on. So it's a function from the natural numbers to true or false. So it's to Booleans, in other words,
Mhm.
um, which appears random and which returns true with probability p. So it is not really random, but the the function is complex enough that the people, we can't study it and invert it easily enough to determine to predict what it's going to do beforehand. So it
Right.
is apparent randomness, and we want it to return true with probability p. So with the we want to have a parameter that we can use to make it more or less difficult.
Right. And this brings to mind some of the things we were talking about in terms of hash and hash function, which is that the need to appear random is a key indicator of the success of the function. Because if the function does not create apparent randomness, then it's not a good function. You need a better function.
Right. And if you were to read a cryptography book, there'd be, several hundred pages on what apparent randomness really means, but we're skipping over that. So proof of work is an application of the handicap principle. And so here's my slide for that. So the original idea of proof of work is for spam prevention. So anyone who wants to send you an email needs to retrieve your proof of work puzzle, and you want to create a new puzzle for each person, right? Because once one person, well, for each instance, because once that puzzle is solved, then you can't give it out again because we know the answer. Oh, and there's something that I forgot to explain. The idea is, I told you in the last slide, we create this function, and then the idea is I give the function to you, and you have to find an input such that the function returns true. Okay, that is the puzzle. I create it, and then you find the input that returns true. And I know,
and the probability there is talking about how difficult it will be for me to find the input. So something with a very small chance, a very small probability, is going to be much more difficult for me to find than something with a very high probability, right?
Right. So I can adjust the difficulty based on how much information I want to look at and how much I need to sift through.
Gotcha. How easy it is for those inputs to be found by how many people, because the more people that find it, the more information you're going to then allow yourself to see.
Right. So for my next slide, I have the handicap principle, and proof of work is an application of the handicap principle. And the handicap principle is another larger idea that I would like to do a whole episode on eventually. But the basic idea is that a handicap is a provably spent resources. So I have a picture of deer with antlers here, and the antlers are the handicap, and he has to spend resources to grow them. And the reason he does that is it is a provably fair, a provably reliable signal, because only strong bucks can grow big antlers, or I should say, can grow them and still have enough energy left over to survive. All right, and that's what we're doing with spam prevention. So I'm saying you have to have a handicap, and if I can see the handicap, then I will look at your message, because I think that someone who is willing to handicap is someone who is more likely to have something that I would want to actually read.
It's interesting, a little bit of a digression, but it makes me think of things like my Blessed Mother pointing out that if you wrote thank you notes to people on, real stationery with good handwriting, you were signaling already that whatever message you were sending needed to be looked at as opposed to not looked at. It's an interesting kind of iteration of a idea that goes something like, those things, people that make an effort, are worth paying attention to more than those things that do not.
Right. And so you've probably heard of, I should say, well, the handicap principle is an idea from biology, but it has applications everywhere. So you might have read The Theory of the Leisure Class by Thorstein Veblen, and he complains a lot about conspicuous consumption. But actually, conspicuous consumption makes a lot of sense, and not just humans do it. You know, all life on Earth does it to try to make connections with other life, and usually this is studied in the context of sexual contests, but it has applications really all over the place. And different animals of different species can use it if they need to. They have some kind of like a symbiotic relationship with one another. They can have a handicap signal to prove that they're going to cooperate, and so on.
No, it's interesting because again, this is digressing from proof of work, but it's making me think about things like sort of more fundamental chemistry and physics and energy exchange, and it's a really profound metaphor, no? That seems to sort of
no, I actually think that the handicap principle is the unifying principle between biology and physics.
Love that, because I was always happiest in chemistry, and it just always seemed to me to be a bridge, and it entirely makes sense in terms of even the math of chemical equations. So,
and I should say a principle, not the principle, but it is.
Yeah, I got a little excited there. He has the principle.
No, yeah, it is, but it is a very profound. It's a profound link between physics and biology.
That's awesome. Okay, so we have the handicap principle, and we have the idea that in order to get through the barrier, you have to have expended sufficient energy. And in this case, in this context, it's that you have to have found the input to a puzzle, and the exercise of doing whatever is required, spending the actual energy to find those inputs, is an indication of your handicap.
Right. And I guess I should have put a citation to the paper that was cited by Satoshi, but it was by Adam Back, and I'll find the link to it, and you can post it in the posted below. So next we're going to talk about cryptographic hash functions and how you can create a proof of work system from a cryptographic hash function. So I've got some review, and remember last time when we talked about cryptographic hash functions, we learned that means it's a function from the message space to the digest space that appears random and cannot be inverted. And there's an extra special condition that I didn't bother to reiterate here, but you can't create given a hash and a message that produces the hash, you can't produce a second message that also produces the hash. So right. That's what cannot be inverted means in this context. So it's slightly stronger than just if you have a hash, you can't find a message that produces the hash. And you don't really need to know that, but if you ever take a cryptography course, you probably they might try to catch you with that on a test or something.
Right, it's an important nuance. Got you.
Yeah, and I've included the definition of message space, and that's just natural numbers again, because remember, every message can be written as a series of ones and zeros, and that is a number. And the digest space is numbers up to a fixed length. And the cryptographic hash function goes from the message space to the digest space. And,
okay, so you say fixed short length. What do we mean by short?
Right, so that usually means 180 bits or 256 bits, something like that.
Yep.
And So how do we do proof of work with that? Well, we basically I create a string, and there's a blank in it, and I say fill in the blank such that the full the hash of the complete string has a certain number of leading zeros, or is less than a certain amount. So I just pick a fraction of the digest space, which is 180 bits or 256 bits or something like that, and that's how I choose p. Remember, p is the probability that I want to give you.
Yep.
And I have to pick a string, or pick a string with a blank, because I need to make a new puzzle each time.
Yep.
And then you have to fill in the blank, and that is that's the proof of work system right there, and that's what Bitcoin uses, and it uses the hash function SHA-256. But you can do this with any hash function as long as it works. And there are other ways of implementing proof of work that do not use a hash function, but the hash function is a convenient way of doing it. But I might mention Primecoin, because they have a system that doesn't use a hash function. Just as an example, I don't know if they're even still around now, but they was invented in 2013, and the idea is that instead of hashing, you search for large primes.
Right. Right. So tell me the difference between, and this may seem like a super basic question, but tell me the difference between the kind of prove that I am not a robot CAPTCHA way of filtering and hash function. Is it simply the case that you're looking for an input that a human actually can't come up with, and therefore you need to have computing power to do that?
Sure. Well, yeah. The proof of work isn't choosy. It doesn't require intelligence. It's just energy expanded, or computations expanded, because technology could change so that it takes different amounts of energy to solve the same puzzle. But the point is that it's adjustable. Whereas the CAPTCHA, that's intended to be something that computers ordinarily don't know how to do. But those aren't going to work for too much longer.
Right. Because you're moving into the space of computers being able to do things that are not simply brute force that a single human can't do in a gazillion lifetimes. So I think the other thing that I think is worth mentioning is that you and I have discussed a little bit before the difference between having a function that is the most difficult and a function that is difficult enough for your purposes, and how that relates to literal energy expansion, and the critique that can be made of proof of work as an energy wasteful or problematically large consuming energy exercise.
Well, let's conclude on that, because I guess I'll just take examples from nature again. Well, I guess I don't want to talk yet about why we need the reliable signal in Bitcoin, but it's about solving the double spending problem. We need to come to a consensus, and you need to expending energy is the cost of coming to consensus, because Bitcoin is worth a lot. So people are willing to expend quite a bit of energy in order to get some. So the optimal amount right now is very high, but in the long run, what it really means is that we're going to have more efficient use of energy, because now we have something to do with every bit of energy that can be extracted. And I'm citing Mark Wilcox for this particular point, and I recommend his article, "Fundamental Misconceptions." But it is it, it, because there is this incentive to use every available bit of energy, that means we're going to be more efficient at extracting energy, and not all of that is going to be used for proof of work. It's going to be used for, whatever we need energy for.
Right. No, I mean, I happen to agree with you and the premise, but one of my particular points of interest is how this will drive the adoption and use of alternative renewable energy sources in a way that previously there had not been this kind of incentive industrial case. So that to me is also one of the things that can get lost when people start talking about how problematic or whatever other word, Bitcoin particularly, its energy use consumption is, and it's, I think, a more complex set of if A then B then C than most people realize.
Well, let's conclude on that, because I got to go. But yeah, I want to revisit that topic when we talk about how proof of work works in Bitcoin itself. But there's a lot more to go over.
For sure, including what is consensus. So
Oh,
see
that's
you
a
next
good one.
time. Exactly. Stay
See ya.
tuned. Bye.
Bye.